Hello students, welcome to memoneet. This is Ravikant, your physics teacher, and today we are going to discuss your BPT 18 question paper, right? So let's start with it. So the very first question says that a magnet of moment 4 ampere meter square is kept suspended in magnetic field of induction 5 into 10 to the power of minus 5 Tesla, the work done in rotating it through 180 degree, right? So the formula for the work done in rotating a magnetic dipole, or you can a bar magnet in a magnetic field, is given as W is equals to M B into 1 minus cos theta, where theta is the angle to which it is to be rotated. So W will be equals to M B 1 minus cos 180, and cos 180 is minus 1, so this would result in W is equals to 2mb. So we have the value of m as 4 and b as 5 into 10 to the power of minus 5. So 2 into 4 will give you 8 and into 5 will give you 40. So your correct answer for this first question will be option 1, right? So the correct answer will be option 1, that is 4 into 10 to the power of minus 4 joule, right? Now next, coming to your second question. Now if a load of 9 kg is suspended on a wire, the increase in length is 4.5 millimeters. The force constant of the wire is, so the force F will be given as F is equals to Kx, right? F is equals to Kx. So if you can see, the increase in length is given as 4.5 millimeter, which can be written as 4.5 into 10 to the power of minus 3 meters. Load which is applied is of 9 kg, so the force will be equals to 9 into 10 to 9 into 9.8 Newton. F is being given by the formula F is equals to Kx. So now we will be putting the value. So F is equals to 9 into 10, 9 into 9.8 is equals to K into 4.5 into 10 to the power of minus 3, right? From here we'll have to calculate the value of K, and we get the value of K as 1.96 into 10 to the power of 4 Newton per meter, and this is what is known as force constant. So this matches with the second option of our question. So the correct answer for question number 2 is option 2. Now coming to question number 3, 1 mole of an ideal gas undergoes a process which is described by a relation P is equals to P naught upon 1 plus V naught upon V square, where P naught and V naught are the constants. Change in the temperature of the gas when volume is changed from V is equals to V naught to V is equals to 2 times of V naught, right? So this is, so the process is being given with the help of an equation, right? So the equation which they give is that P is equals to P naught upon 1 plus V naught upon V whole square, and the volume is changing from V naught to 2 times of V naught, right? So initial volume is V naught and final volume is 2 V naught. So change in volume will be V naught, right? So if we look into it, see, this is the expression which is given for the process, and we know that P is equals to nRT upon V. This is the gas equation. PV is equals to nRT. So from there we get P is equals to nRT by V, right? So this can be written as 1 into, for 1 mole. For 1 mole, putting n is equals to 1, it becomes RT upon V. So P is equals to, here we get P is equals to RT upon V, right? So now in place of P we can write RT upon V. So RT upon V is equals to P naught into 1 plus V naught upon V in the whole square, right? So now from here, if we isolate T, V will get multiplied here and R will divide it here, it becomes in the denominator. So we get T is equals to Vp naught upon 1 plus V naught upon V square into R. So for V is equals to V naught, this expression becomes T1 is equals to V naught into P naught upon 1 plus V naught upon V naught square into R. Finally, it results in T1 is equals to V naught P naught upon 2R. Then for V is equals to 2R, putting similarly, we get T2 is equals to 8 V naught P naught upon 5R. So to calculate the change in temperature, we will subtract T2 minus T1, and this would result in 11 P naught V naught upon 10R. And this matches with the second option of this question. So the correct answer for question number 3 is option 2, right? Question 3 is option 2. Now let's come to question number 4. In the system shown in the figure, the acceleration of 1 kg mass and the tension in the string connecting between A and B is. Okay, so see, to solve this question, we will have to draw the free body diagram, right? So let's take space and draw the free body diagram. Yes. So there are three blocks, right? So if I first start with this, and we assume that this is accelerating like this, we are taking that the acceleration is in this way. Then for block C, let the block C be like this. Block C is of 3 kg. So there is one tension in the string. This we will mark it as T1. Where is T1? Here in the figure you can see this will be T1. This will be T1 because the same string. This will be T2 and this will be again T2. So for C, block C, T1, here you get 3g, that is the weight of the block, and finally you get acceleration A. So from here we can write the equation as T1 minus 3g is equals to 3a, and we mark this as our first equation, right? Then for block B, this is again of, let me write block B here, it is again of 3 kgs. So you can see here in the upward direction it has T1, then in the downward direction it will have its weight, that is 3g, as well as it will have tension T2, and because of this it is accelerating downwards. So for this we will write the equation as, the equation for B I am writing here, equation for B, it will be your 3g plus T2 minus T1 is equals to 3a, is equals to 3a. So this will be our second equation. This will be our second equation, right? Then for block A, let me draw it here. For block A, it is of 1 kg. We have tension T2 here and 1g here, and the acceleration is this way. So the equation will become your 1g minus T2 is equals to A, right? So this is our third equation. Now using these three equations and solving it for T2 and A, we get T2 as g by 7 and we get A as g by 7 and T2 as 6g by 7. So what are the three equations we are having? I am writing out three equations here. You must solve it simultaneously and get the answer of equation. The first equation is your T1 minus 3g is equals to 3a. Second equation is Second equation is your 3G plus T2 minus T1 is equals to 3A, and the third equation is third equation is where did I write it? Third equation will be your this T2 plus G minus T1 is equals to A. This is your first equation. This is the second one. Yes, this is the third. G minus T2 is equals to A. Yes, sorry. G minus, third equation will be your G minus T2 is equals to A. So solving this, you will get your acceleration as G by 7 in the downward direction, and tension in the string between A and B, that is T2, will be equals to 6G by 7, right? The equations are important. So if you want the solution, we can do it. We have space here. So it is using the second and third equation. Second equation is 3G plus T2 minus T1 is equals to 3A, and the third equation is G minus T2 is equals to A. So G minus T2 is equals to A, right? Now if we add them, this will become 4G, T2 gets cancelled out, minus T1 is equals to 4A. So from here we get T1 is equals to 4 times of G minus A, right? Now we can put this T1 here and we will get the value of A, right? So if you put the T1 here, you will get 3G plus 4G minus 4A this is put T1 here, right? Put T1 here instead of placing it here. You put T1, wait. So we got T1 as T1 is equals to 4G minus A, and we put this in the first equation, so we get 4G minus 4A minus 3G is equals to 3A, right? So from here you will get G is equals to 7A, so your A is equals to G by 7. So you are getting A as G by 7. So when you are getting A as G by 7, then again you use this value of A and put in any one of the equation having T2, you will get the value for T2 as 6G by 7, right? Now coming to question number 5. So the correct answer for question number 4 is option 3, right? So coming to question number 5, the heat is conducted across a composite block of two slabs of equal area and having thickness as D and 2D. Their thermal conductivity are 2K and K respectively. If two faces of composite rod are maintained at temperature 100 degrees centigrade and 0 degrees centigrade as shown in the figure, and there is no heat loss from the rod, then temperature of the junction will be. So the question could be understood by this diagram. There is a block. First block is of the thickness as D. Another block is of a thickness 2D. One end is at temperature 100 degree centigrade, another is at 0 degree centigrade. We are supposed to calculate the temperature of the junction, that is at point E, right? And because it is in steady state, so the rate of flow of heat for the first block will be equal to the rate of flow of heat in the second block, right? So let's look into this. So rate of flow of heat is being given by the formula Q by T is equals to Ka dt by d. dt means the difference in temperature, right? So for the first block, the thermal conductivity is given as 2K. So Q by T will be equals to 100 minus T. So here the temperature is 100 and here we are taking temperature as T. So here the temperature difference will be 100 minus T. So 100 minus T up into 2K, that is the thermal conductivity, into A upon D, right? Similarly, for the second block, which has its thermal conductivity as K and thickness as 2D, we will get Q by T is equals to T minus 0. T minus 0 because the heat is flowing in this direction, right? So T minus 0 into Ka upon 2D. Now, because here it is the case of a steady state, therefore rate of flow of heat in the first block will be equal to rate of flow of heat in the second block. So the equation 1 and equation 2 can be equated, and equating and solving for T, we get T is equals to 80. So the correct answer for question number 5 will be option 4, that is 80, right? So the basic concept used here is the rate of flow of the heat in both the blocks is constant, and you should know the formula for rate of flow of heat, that is Q by T is equals to Ka dt upon T, dt or delta T. You can write it dt or delta T. That delta T means basically the change in temperature, the difference in the temperature of the two ends of the rod. Question number 6 says that when an AC source of EMF E is equals to E naught sine 100t is connected across a circuit, the phase difference between the EMF E and the current I in the circuit is observed to be pi by 4 as shown in the figure. It's shown in the diagram. If the circuit consists possibly only of RC or RL or LC in series, find the value of these two. So if from the diagram we can see that the current, yes, the current is leading the EMF by the phase, right? So current is leading by pi by 4. Now because the current is leading, it will be it will be RC circuit. It will be an RC circuit, right? So as we can see here, as the current is leading the voltage by pi by 4, it will be an RC circuit. Now here we will be using what? Impedance triangle. So for an impedance triangle, if this is phi, then this will be R, this will be XC minus XL. So here XL is not there, so it will be XC and this will be Z, right? So from here we can say tan phi. Tan phi is equals to perpendicular upon base, so XC upon R, right? XC upon R. So phi is being given to us as pi by 4. So putting phi as pi by 4, and XC is, we know that XC, that capacitive inductance, capacitive reactance, is equals to 1 over omega C. So we put XC as 1 over omega C. So it becomes 1 upon omega C into R, right? So because tan pi by 4 is 1, we can write 1 by omega C R as 1. And from the equation in the question we get E. Here we know that E is equals to E naught sine 100t. So from here we get omega is equals to 100. So we put omega as 100. So putting omega as 100, we get CR is equals to 1 upon 100 second. From the given options, we get the option 1 correct. That is, for the combination of resistance to be of 1 kilo ohm and capacitance as 10 microfarad, we get CR as 1 upon 100 seconds inverse. The rest in any one of them, we do not get the same result. So the correct answer will be option 1, right? The correct answer for question number 6 is option 1. Now coming to question number 7. Question number 7 says that a critical angle of a light going from medium x to medium y is theta, right? Now the speed of the light in medium x is v. So the speed of light in the medium y is, see, the light is, suppose this is the interface, this is medium x and this is medium y. Now if we are talking about critical angle, definitely the light is moving from a denser medium to a rarer medium. So light is going from medium x to medium y. It means medium x is denser and medium y is rarer. So the incidence angle theta will be in x and the refracted angle 90 degree will be in y. So this would be the case. Light ray is going like this. This would be the normal. This is theta, right? And the refracted ray will be going like this, and this is 90 degrees. So using Snell's law, let me write it here. So yes, we can see it. Using Snell's law, sine theta upon sine 90 is equals to mu y upon mu x, right? So because sine 90 is 1, so sine theta is equals to mu y upon mu x. What is mu y? Mu y is refractive index of medium y. This can be written as c upon velocity in y. Similarly, mu x will be equals to c upon v x. Now we have mu y upon mu x, so dividing these two, the c and the c cancels out and this becomes reciprocal. So what we get is sine theta is equals to Vx upon Vy. They are asking us to find the speed of light in medium y. So speed from this Vy goes that side and sine theta comes this side. So from here we get Vy is equals to Vx upon sine theta, and Vx is to be taken as V as told in the question here. So final answer is Vy is equals to V upon sine theta, which is option 2. Now coming to question number 8, when the number of turns on the number of the turns and the length of the solenoid both are doubled, its self-induction becomes. So the formula for the self-induction of a solenoid is given as L is equals to mu naught n square A into I, right? Sorry, A into L. L here is the length of the conductor. N, small n, is the number of turns per unit length, right? Number of turns per unit length. So the length is equals to n upon L. Now see, the formula is L is equals to mu naught n square A into L. This small n is number of turns per unit length, so we can write it as mu naught into capital N square upon L square into A into L. So this L and a power of L goes off, right? Now what they are saying that this capital N is made doubled and this small l is also made doubled. So when we are making this capital N double, it becomes 4 here because of the square, and this L is made 2 times. So this cancels out and result in 2, right? Results in 2 times of mu naught n square A by L. So what we find is the final inductance is twice of the initial inductance. So when the number of turns is made doubled and the length is made doubled, then the final inductance becomes the double of the initial inductance. So according to this, the correct answer for question number 8 will be option 2, right? Now coming to question number 9. Question number 9 is your match the following. For the column 1 and column 2, we are choose capillary of smaller radii. So capillary of smaller radii would result in no flat meniscus, no greater height acquired by the liquid. Yes. So A goes with Q, right? Angle of contact as 90 degree, flat meniscus. So B is with P. So this is very clearly we can see that A is with Q and B is with P is in option 1, right? So the correct answer for question number 9 is option 1. Coming to question number 10, a dip angle vibrates in wait a minute. Yeah. A dip needle vibrates in the vertical plane perpendicular to the magnetic field. The time period of the vibration is found to be 4 seconds. The same needle is then allowed to vibrate in the horizontal plane and the time period of is again found to be 4 seconds. Then the angle of dip is, see, because here the time period is same, from here itself we can guess that if the time period is same, it means the magnetic field will be equal. And because the magnetic field is equal, that is the horizontal component of magnetic field and the vertical component of magnetic field are equal. Therefore, the angle of dip will be equals to 45 degrees. So from there we can say that option 4 is the correct answer. But still, if we want to get into the mathematics, we can say that in the vertical plane perpendicular to the magnetic meridian, therefore, time period is given by 2 pi under root L by m BV, where this BV is the vertical component of magnetic field. Similarly, for horizontal component, time period is equals to 2 pi under root L by MVH. So BH here is the horizontal component. Now equating these two, because the time periods are same, equating these two will get BV is equals to BH. And now because BV is equals to BH, so angle between them will be, so the angle bit of dip will be equals to 45 degree, right? So the correct answer for question number 10 is option 4. Coming to question number 11. Question number 11. Two coherent monochromatic lights beam of intensity I and 4I are superimposed. The maximum and minimum possible intensity of the resulting beam is. So resulting beam I, intensity of the resulting beam I is equals to under root of I1 plus under root of I2 whole square. This is for maximum, and I minimum is equals to under root of I1 minus under root of I2 whole square, right? So if I1 is 1 and I2 is 4, so it becomes 1 plus 2 whole square, so it will be equals to 9. So maximum I max will be equals to 9I, and for minimum it would be equals to 1 minus 2, which is equals to minus 1, and minus 1 square is equals to 1, so it would be I. So 9I and I. So option 3. Using this formula and putting the values, see, I1 is given as I and I2 is given as 4I. So under root of them will be equals to I and 2I. So from there we can calculate I max and I minimum. So I max, see, I max is equals to under root of I1 plus I2 whole square. So I1, under root of I1 will be I, and under root of I2 will be equals to 2 times of I and square of this. So this is equals to 3I, and 3I square will be equals to how much? 9I square. Oh, sorry, root I na, root I. Right? So this will be equals to 9I, and for minimum it will be I. Now coming to question number, so the correct answer for question number 11 is option 3. Coming to question number 12, a particle of mass 2 kg located in the position this, that is I cap plus j cap meter, has a velocity of 2 I cap minus j cap plus k cap meter per second. The z component of the angular momentum about origin is. So angular momentum is linear momentum into r, that is the cross product of r, that is L is given as r vector cross p vector. So because the mass is 2 kg and the position is I cap plus j cap and the velocity is this, so if we multiply this velocity with the mass, we'll get the linear momentum. So multiplying mass with the velocity, we get linear momentum p vector as 4 I cap minus j cap plus k cap. Now when we make the cross product of this linear momentum with the position vector r vector, doing the cross product, we get our angular momentum as 4 I cap plus 4 j cap minus 8 k cap. So the z component for the momentum is, angular momentum is your 8. minus 8, sorry, it's minus 8. So the correct answer for question number 12 is minus 8, right? So what we are using here is first P vector is equals to your 2 times of V vector because mass is given as 2 and angular momentum is equals to R vector cross P vector. What is R vector here? This is R vector, position vector, right? And finding the cross product of this will give the Z component of the angular momentum as minus 8 as shown here, right? So the correct answer for question number 12 is option 4. Coming to question number 13. Question number 13 says that the mean free path for molecule of a gas is 1 by root 2 pi centimeter. If number density of gas is 10 to the power of 8 per centimeter cube, then the diameter of the gas molecule is. We have a direct formula for the diameter. See, if mean free path lambda is equals to 1 by under root 2 pi and n is the number density. We have the formula as d square is equals to 1 upon under root of 2 pi n lambda, right? Using this value, putting the values, using this formula and putting the values, we get diameter as 10 to the power of minus 4 centimeters, right? So the correct answer for question number 13 is option 1. It's directly formula based question. You should know the value formula and put the value, right? So d square, that is the diameter of the gas molecule, is equals to 1 upon 2 pi n lambda. Coming to question number 14. Question number 14 says a solid cylinder rolls down a plane of length L and is inclined at an angle of theta without slipping. Its velocity on reaching the bottom will be. Okay. So diagram has not been given to us. So we have the diagram in the solution. So the velocity of the cylinder at the bottom, we take it as V, and in this situation this will be the diagram. If this is the height h, if this is the height h, then this length L will be equals to h will be equals to L sine theta. H will be equals to L sine theta. Now it is rolling from here. So at this position it has the potential energy which is equals to mgh. Now this entire potential energy at this end converts into rotational kinetic energy and translatory kinetic energy. So using the law of conservation of energy, your potential energy is equals to kinetic energy plus rotational kinetic energy, that is mgh is equals to half mv square plus half I omega square. So this I over here is an moment of inertia of a solid cylinder about its axis. So moment of inertia of solid cylinder about its axis is given as mr square by 2 and omega is given as v by r. Putting these values in the first equation of law of conservation of energy, we get mgh is equals to 1 by 2 mv square plus half mr square by 2 into v by r whole square. Solving this, we get v is equals to under root of 4gl sine theta upon 4, which matches up with the option in question number 14 as your option 4 by 3, option 2. So the correct answer for question number 14 is option 2, right? Now getting to question number 15. Question number 15 says that in the circuit shown below, the phase difference between the voltage and the current is phase difference. Again, we'll use the impedance triangle here. If we draw the impedance triangle, we may write it as VL difference VC, VL difference VC, and this will be VR and this will be V. So if we look into the question, this is V given to us, this is V given to us, this is VL given to us, and this is VC given to us. So VC is 100, VL is 60. So this would result in 40. That is VL and VC differences of 40. And effective voltage is 50. So this hypothesis is 50. We need to calculate the phase angle phi. right? So from here we can use sine phi. So here see, sine phi is equals to VC minus VL upon V. So it becomes 40 upon 50 will be equals to 4 over 5. So sine pi is equals to 4 over 5. So sine inverse of 4 upon 5 will give you phi as 53 degree, right? So the correct answer for question number 15 is option 2, that is 53 degree. So this question can be easily solved using the impedance triangle. So you should know what impedance triangle is. Coming to question number 16, it says a particle move in an xy plane according to the relation x is equals to kt and y is equals to kt into 1 minus dt, where k and d are the positive constants and t is time. What is the equation of the trajectory of the particle? So if it is moving in an xy plane, put the value of t in terms of x in y, right? So from here we can say if x is equals to k t, then we can say t is equals to x upon k. Now putting this value of t in the expression of y here and solving it, we will get, see, we have put the value here, we get kx into k upon k into 1 minus d into x upon k. D into t की जगह पे we are putting d into x by k. Solving it, we get y is equals to x minus x square d by k as the equation of the trajectory. So the correct answer for question number 16 is option 3. So the only thing which you have to do is get the value of t in terms of x and put that value in the expression of y, so that we have the entire expression in terms of x and y, and solving it will give the correct answer as option 3. Now coming to question number 17, that if y is equals to x raised to the power of x, then we have to find dy by dx, right? So to solve this, what we have to take? We have to take log on both the sides. See, now we have y is equals to x raised to the power of x. So when we take log on both the sides, it becomes log y is equals to log x raised to the power of x. So it becomes log y is equals to x log x. Now differentiating both the sides with respect to x, it becomes 1 over y into dy by dx. Then here we have two functions, function 1 and function 2. So differential of first function differential of second plus second function differential of first, right? So this would result in, see, first function differential of second, differential of log x is 1 upon x, plus second function, that is log x, differential of x is 1, right? So from here we get dy by dx is equals to x power x into 1 plus log x. So the correct answer for your question number 17 is option 2, right? Option 2. I hope you understand this. Let me show it to you if you want. We have equation as log, let me write it here. We have log y is equals to x log x. So when we are differentiating both the sides with respect to x, log y becomes 1 upon y, and because we don't have x here, so we'll write it as dy by dx, right? This is equals to, now we have two functions here. The first function differential of second, so log x differentiated with respect to x will give you 1 upon x, plus second function. What is second function? Second function is log x differential of first. What is first? X. So differential of x is 1, so it remains same. Now this x and x cancels out. What we are left with is 1 upon y dy by dx is equals to 1 plus log x. Now they are asking us to give the value of dy by dx. So this y goes this side. So it becomes y into 1 plus log x. What is y actually? Y is your x raised to the power of x. So our final answer becomes dy by dx is equals to x raised to the power of x in place of y and into 1 plus log x. So this is our option 2. Coming to question number 18. Question number 18. So question number 18 says that the two polarides are crossed to each other. Now one of them is rotated through 60 degrees. The percentage of incident unpolarized light that transmits through the system will be. So when it is passing through first polaride, its intensity will become half. So for the first polaride, its intensity becomes half. Now they are turned by 60 degrees, so the angle between them will become 30 degrees, right? So using the formula I2 is equals to I1 into cos square phi, where phi is 30 degree here. Putting the value, we get the new intensity out of the second polaride is 3 by 8, right? So 3 by 8 of the initial intensity, and when we convert it into percentage, we find the percentage to be as 37.5%. So the correct answer for question number 18 is option 2. So the thing which we have to use to solve this question is that when the light ray passes through the first polaride, its intensity becomes half. Then when the is rotated by an angle of 60 degree, then the angle between the polaride will be equals to 90 minus 60, which is equals to 30. And then using the formula, I2 is equals to I1 into cos square phi, where phi is the angle between the polarides. Putting the value, we will get the answer. Now question number 19. Question number 19 says the temperature of a gas is increased from 127 degrees centigrade to 527 degrees centigrade. The RMS speed of gas molecule will increase by a factor of. Now at initial temperature, which is at 127 degree centigrade, when converted into Kelvin, it becomes 400 Kelvin. And the final temperature when converted into Kelvin becomes 800 Kelvin, right? So from here we can say in terms of Kelvin, the temperature had become doubled, right? Temperature become doubled. So the formula for the RMS velocity V is equals to under root of 3 RT by M, 3 RT by M. So initial is 800. So if we compare, so if we compare the initial final velocity, this we get is V is proportional to under root of T. So V1 upon V2 or V final upon V initial will be equals to under root of T final upon T initial. So from there we get T final is 800 and T initial is 400. So from there we get a factor of root 2. So by the factor of root 2, the temperature will change. So the correct option is option 3, right? V is proportional to under root of capital T. The thing which is to be kept in mind here is that T is to be put in Kelvin. In the question, they have given the temperature in degree centigrades. Convert it into Kelvin and then solve. You'll get the answer as root 2. Right? Now coming to question number 20. Question number 20 says a calorimeter of mass 1.5 kg, copper calorimeter of mass 1.5 kg has 200 grams of water of 25 degrees centigrade. 510 grams of water at 50 degrees centigrade is poured into it such that the equilibrium temperature becomes 40 degrees centigrade. Alright. If specific capacity of copper is 390 joule per kg per degree centigrade, then find the specific capacity of water. So here we are supposed to use the principle of calorimetry. What principle of calorimetry says that what heat lost by a body is always equal to the heat gained by a body, right? So the heat is being lost by the 510 grams of water, which is at 50 degrees centigrade, and heat is being gained by 200 grams of water, which is at 25 degrees centigrade, and 1.5 kgs of copper, which is again at a temperature of 25 degrees centigrade. So if we get into heat lost, so heat loss is equals to mc delta T, that is mass of the substance into its specific heat capacity into change in temperature. So change in temperature, as it has been given in the question, the final temperature is 40 degree. So water at 50 degree will be losing temperature. So after losing temperature, it is reaching to 40 degree. So what is the change in temperature? The change in temperature is 10. So putting the value of mass, specific heat capacity and change in temperature, we get amount of heat lost is 5100 into specific heat capacity of water. Now heat is gained by the calorimeter and water. So heat gained by calorimeter will be equals to mass of calorimeter into specific capacity of calorimeter into change in temperature. So for calorimeter and 200 grams of water, what is the change in temperature? They were initially at 25 degrees centigrade and finally they reached to 40 degrees centigrade. So change in temperature will be 15 degrees centigrade, right? So Q1 is equals to mass of copper vessel into specific heat capacity of copper, which is given as 390, and into delta T, which is equals to your 15 degrees, plus mass of water into specific heat capacity of water into delta T is again 10 degrees. Putting the values and solving, we get it as 8775 plus 3000 specific heat capacity of water. Right? Now, using the principle of calorimetry, heat loss is equals to heat gain. We equate the two heats obtained above and then we solve it. So, we get the specific heat capacity of water as 4.18. So, the correct answer for question number 20 is 4.18. So, the basic principle utilized over here to solve the question number 20 is that he is the principle of calorimetry, which says that the amount of heat loss is equals to amount of the heat gained. Who is losing heat here? The water, 510 grams of water at 50 degrees centigrade is losing heat here, and who is gaining heat here? The calorimeter of mass 1.5 kg and water 200 grams of water are gaining heat. What are the initial temperature of calorimeter and water? It is 25 degrees centigrade, and what is the final common temperature? It is 40 degrees centigrade. Right? Using the principle of calorimetry, we can solve this and we get the answer of specific capacity of water as 4.18. Coming to question number 21, the ratio of the radii of a radii of gyration of a circular disc about its tangential axis in the plane of the disc and a circular ring of the same radius about its tangential axis in the plane of the ring is. So, they are asking about, suppose this is a disc, so the axis is this tangential axis in the plane of the disc, and if suppose this is a ring, then tangential axis in the plane of the ring. So if we know the moment of inertia along the diameter for the ring and moment of inertia along the diameter for the disc, using parallel axis theorem, we can easily calculate the moment of inertia about these two axes and then we can find the ratio. So for your circular disc, the moment of inertia about the diameter is 1 by 4 mr square. So using parallel axis theorem, it will become 1 by 4 mr square plus mr square, which gives you 5 by 4 mr square. When it comes to the circular ring, the moment of inertia about its diameter is mr square by 2, and using the parallel axis theorem, you add it with mr square, it becomes 3 by 2 mr square. So for the ring it is 3 by 2 mr square, and for the disc it is 5 by 4 mr square. And when we find the ratio, the ratio for the radius becomes your we find the ratio, the ratio of gyration becomes under root of 5 upon under root of 6, right? So K, that is radius of gyration for the disc is root 5 by 4r. Radius of gyration for the ring, it is root 3 by 2 into r. Finding the ratio of this will give you root 5 upon root 6. So which is the correct answer? The correct answer for question number 21 is your root 5 upon root 6, which is option 2. Right? Now coming to question number 22. The magnetic field due to a short bar magnet of magnetic dipole moment M and length 2L at a point P, which is a distance R from the center of the bar magnet, is shown in the figure, is given by. So we have studied in electrostatics that electric field at any point by an electric dipole is given as, you can see, electric dipole, electric dipole E is equals to K, that is 1 by 4 pi epsilon naught 2p cos theta upon 2p cos theta upon r cube, right? So here theta is given to us as 30 degrees. So if we put the value as 30 degree, we'll get for similarly for the magnet, bar magnet, we can use the formula. We'll get B. B is equals to mu naught upon 4 pi into 2m into cos theta upon r cube. Cos theta, cos 30 here. Cos 30 will be root 3 by 2. So solving it will give you B is equals to mu naught upon 4 pi root 3 times of m upon r cube, right? So root 3 times upon, this is the answer. So the correct answer for question number 22 is option 3, that is root 3 times of mu naught upon 4 pi m upon r cube. What is the formula which we are using? Taking the reference of electric dipole, electric field at any random point is given by k, that is 1 by 4 pi epsilon naught there, epsilon naught for electrostats is equals to 2p cos theta upon r cube. So here for magnetic field, because of a bar magnet, it's or a magnetic dipole, we can write it as B is equals to mu naught upon 4 pi into 2m, that is magnetic dipole moment, into cos theta upon r cube. Putting this value, putting theta as 30 degree and solving it, will get our correct answer as option 3, right? So the correct answer for question number 22 is option 3. Coming to question number 23. Yes, coming to question number 23. The first diffraction minima due to a single slit diffraction is at 30 degrees, alright, for a light of wavelength 500 angstrom. The width of the slit is, so width of the slit, we know that sine theta for diffraction, sine theta is equals to lambda upon a. Here we are asked to calculate a. Lambda is being given as 500 angstrom and theta is being given to us as 30 degrees. So simply put the value, you will get the answer, that is your sine, you can see it here. Sine 30 is 1 by 2 is equals to lambda upon a. So calculating this, a is 10 into 10 to the power of minus 5 centimeter, which is the correct answer is option 2 for question number 23, right? So the correct answer for question number 23 is option 2. Now coming to the next question. The next question is question number 24. Question number 24. Now for a given cyclic process as shown in the pressure volume graph, the net heat supplied to the system is, see, this is a cyclic process, so there will be no change in internal energy. So we have delta U is equals to delta Q is equals to delta U plus delta W. So delta U is 0 here because it is a cyclic process. So delta Q will be equals to delta W. So delta W for a cyclic process, this area under the curve is known as, is equals to delta W, and if we calculate this, we'll get delta Q, right? So heat supplied to the system will be known. So for this, we calculate the area. So area will be equals to half into base is of 1 and height is 2 into 10 to the power of minus 5 minus 1 into 10 to the power of minus 5. So it will give you 10 to the power of minus 5. So it becomes 0.5 into 10 to the power of minus 5, right? Yes. Yes. 3 upon 2. Yes, this 10 to the power of, it's not minus 5, it's minus 3. Okay, it's minus 3. It is minus 3. So this becomes 500 joules. So the correct answer is option 3. Simply calculate the area under the curve because it's a cyclic process. So delta Q will be equals to delta W, and from the PV curve, the area under the curve will give you the work done. So from here, calculating the area under the curve will give you the amount of work done. The amount of work done will be equal to the amount of the heat supplied. So question number 24 has its correct answer as option 3. Coming to question number 25. Question number 25. The parachutist, which with a total weight of 75 kg, drops vertically onto a sandy ground with speed of 2 meter per second and comes to halt over a distance of 0.25 meter. The average force from the ground on the man is close to, right? So when the parachutist is falling, suppose this is a parachutist, right? This is the parachutist. So acceleration, net acceleration is in upward direction and it is falling in the downward direction. Now they say that while it is drops vertically on the sand ground with a speed of 2 meter per second. So for sand, your initial velocity will be equals to 2 meter per second. Displacement is 0.25 meters. Now the parachute is falling downwards and net acceleration is upwards. So acceleration will be taken as negative. Acceleration will be taken as negative. So we don't have acceleration with us. So using the formula v square is equals to u square minus 2as and putting the values in it. Putting v as 0 because finally it stops. U as 2. A minus 2as. S is 0.25. A is to be calculated. Solving this, we get A as 8 meter per second square, right? So this is the acceleration which the parachutist is having in upward direction. So if suppose this is the parachutist, force in the upward direction is this is the acceleration in the upward direction. So acceleration when multiplied with mass will give you the force. So mass is 75 kgs and acceleration is 8. So it becomes 600 newtons. So in upward direction gets a force of 600 Newton, right? And in downward direction it has its weight. So 75 into G, 75 into G, and there will be a net force on it. Net force in the upward direction. So from the free body diagram, you can say, see, this is the free body diagram. Here we have 600 Newton and here we have your mg, that is 75 into 10, right? Yes, 600 mg, and this is equals to the force from land. So from here we can say that 600, wait a minute, yes, F minus 600 is equals to 750. So your F will be equals to 750 plus 600, which will be equals to 1350, right? So F minus 600 upon, is equals to 750. Solving this will give you FR as 1350 Newton. So the correct answer for question number 25 is option 1, right? Coming to question number 26. Question number 26. It says in a coil, the resistance 100 ohm, a current is induced by changing the magnetic flux through it as shown in the figure. The magnitude of the change of flux through the coil is. Okay, so this graph is giving you the current and time. So see, we know E is equals to minus d phi by dt, right? If I divide this with R on both the sides, it becomes I is equals to minus 1 upon R d phi by dt, right? What they are asking us to calculate is the magnitude of change in flux through the coil. That is, they are asking us to calculate d phi by dt. So we have this. So if we move this dt on this side, we'll get I dt is equals to minus 1 upon r d phi, and integrating both the sides, we'll get the value for d phi. So this equation is represented by this graph. So if I calculate the area under the graph, I will get my magnitude of the phi of the flux, magnetic change of rate of change of magnetic flux. So area for this would be equals to half into base into height. So half into base is 1 and into height is 10, right? So this would give me 5. This would give me 5. Yes. So 500. Okay. So 5, and what is the resistance? Resistance is 100 ohm. Okay. So 5 into 100 will give us 500 Weber, right? So this is the correct answer. Option 3 is the correct answer. So if you see, this integrating this equation is nothing but the area under the curve. So if we take this area under the curve, it comes as 5, and then 5 multiplied with 100, which is the resistance, you get the answer as 500 Weber for the flux, right? See, they have written it or not, I don't know. Yes, see, I is equals to E by R is equals to d phi by dt into 1 by R. So d phi will be equals to 1 I into R dt. Integrating will get phi is equals to integral I R into dt. So integrating I with respect to t means area of the curve, which is coming as 5 into R. R is what? 100. So 5 into 100 will give you 500, which is the magnitude of the flux. Now coming to question number 27. 27 gives us that VI graph of a conductor of at two different temperatures is shown in the figure. The ratio of the temperature TA and TB. See, we know that resistance is directly proportional to temperature, and slope of VI curve gives us the resistance, right? So from here in the graph we can say that TB, that is RB, is greater than RA, or we can say that RB upon RA is equals to TB upon TA, and RB is the slope of graph of TB. So this is angle for TB, angle of inclination, which is 90 minus theta, right? And for RA it is theta. So we can write as tan 90 minus theta upon tan theta is equals to TB upon TA. What they are asking is TA upon TB. So TA upon TB will be TA upon TB will be equals to tan theta upon tan 90 minus theta, and tan 90 minus theta is cot theta, so it will become PA PA upon TB is equals to tan theta upon cot theta. So this will be equals to tan square theta, right? So the correct answer for question number 27 is tan square theta, which is option 1, right? So now coming to question number 28. Question number 28 says the excess pressure inside a soap bubble is equal to a oil column of height 3 mm. The total surface area of the soap bubble in contact with air will be. Density of oil has been given to us, and the surface tension of the soap solution is given to us, right? So here there are two formula which we'll be using. First is rho GH, which is for a pressure due to a pressure inside a liquid, right, at any point, right? Pressure at any point inside the liquid, we get the formula as P is equals to rho gh, and with the help of this, we'll calculate the pressure because of 3 mm height of the oil, and this will be equal to the excess pressure of the soap bubble, and excess pressure for the soap bubble P is equals to 4 RT. Excess pressure is 4, yeah, 4 T by R, 4 T by R. So this pressure is equals to this pressure, so we'll simply equate that rho G H is equals to 4 T upon R. T is the surface tension, G is acceleration due to gravity, H is the height of the oil, and rho is the density of the oil. We have all the values, we need to calculate R. Putting the value and solving it, we get R is equals to your 2.43 into 10 to the power of minus 4 meter. 2.43 into 10 to the power of minus 4 meter is in option 3. So the correct answer for question 28 is option 3. That is how we are getting it. We are equating the pressure because of oil equal to the excess pressure, that is rho g h is equals to 4T by R, right? Next, coming to question number 29. The least count of a stopwatch is 1 by 5. The time of 20 oscillations of a pendulum is measured to be 25 seconds. The maximum percentage error of the measurement will be. So this 2.5 is the least count, so we can take it as delta t, and 25 seconds can be taken as t. So 1 over 5 is equals to 0.2. So delta t upon t into 100% will be 1, 4, 0.2 upon this. So it becomes 0.8%. Is equals to 0.8%, right? So we have 0.8% in our option. Yes, we have it as option 2. So the correct answer for question number 29 is option 2, that is 0.8%. Coming to question number 30. It says the body starts from rest and moves with a uniform acceleration. The ratio of the distance covered in nth second to the distance covered by n seconds. So distance covered by nth second, s nth, is given as u plus a by 2 into 2n minus 1, and distance traveled in n second, s will be given as s is equals to ut plus half a t square. So we have to find this ratio, right? So S nth is Sn u plus a by 2 into n 2n minus 1, right? So putting this u is equals to 0, we get S of n is equals to a by 2 into 2n minus 1, right? The total distance traveled in n seconds will be equals to S is equals to ut plus half a t square. We get it as half a n square. So the ratio comes as 2 upon n minus 1 upon n square, which is your option 1, right? Which is option 1. Question number 30 has its correct answer as option 1, which is 2 by n minus 1 upon n square. Coming to question number 31. If the effective current or is in the given circuit is 2 ampere, means 2 ampere is passing here in both the components, right? Then what is the impedance of the circuit? So to calculate impedance, we should have R and we should have L, right? So if 2 amperes is passing through it and we are having a 90 volts, so V is equals to I into R. So your R will be equals to V by I. So V is 90 and I is 2 ampere, right? Yes, 2 ampere. So this will be equals to 45 ohms, right? This will be equals to 45 ohms. And VL is equals to XL upon XL into I, right? So VL is 120. So 120 is equals to XL, we do not know, and I is 2. So we get XL is equals to 60 ohms, right? And what is Z? Z is right here. Z is equals to under root of XL square plus R square. So putting the value XL as 60 and R as 45, we get Z as 75 ohm. So 75 ohm is in option for question number 31. Correct answer is option 3, that is 35 ohm. Coming to question number 32. 32, two balls, one of mass m and other of mass 2m, are moving towards each other with respect to the with respective speed of 10 meters per second and 20 meters per second on a smooth horizontal floor. Now, if after collision they stick to each other and move as combined masses, then the speed of the combined mass is. So we'll use law of conservation of linear momentum. Initial momentum is C, mass into velocity in positive x-axis, then mass into velocity in negative x-axis. So we are used minus sign, right? That is m into 10 I cap plus 2m into 20 minus I cap. This will give you 10m I cap minus 40m I cap, which is equals to 30m I cap, right? And if we talk about final momentum, so final momentum will be equals to m plus 2m is equals to 3m into v, which we do not know. So because by the law of conservation of linear momentum, this will be minus, minus. This initial momentum of minus 30m I cap will be equals to 3m into v. M and m cancels out, 3 and 30 cancels out 10. So we get v is equals to minus 10 I cap. So this will give you the velocity. So it's minus 10 I cap. So the correct answer is 10, 10 meter per second. So its answer is option 2, 10 meter per second. Coming to question number 33. Question number 33 says a swimmer reaches the other bank of the flowing river exactly opposite to the starting point. If he was swimming at 2 kilometers per hour while making an angle of 150 with the flow, then the time taken by him to cross the river 1 meter wide is. We have the diagram here. This is 1 meter wide river. Let me draw it here. This is the flow of river. If this is the direction of flow of river, the man is swimming at an angle of 2 kilometer per hour. 2 kilometer per hour, and this angle is equals to 150. Now this is the path which he has to cover. So his velocity along this path will be, if this is 150 and this is 90, this would be 60. So velocity along this path will be equals to 2 into cos 60, which will be equals to 1 kilometer per hour. So velocity is 1 kilometer per hour, distance is 1 kilometer, so time taken will be 1 hour. So the correct answer is option 2, right? Explaining it again, this is the velocity of flow of river. This is the direction and the velocity of the swimmer. This is angle of 150. He need to cross along this line. So his velocity of 2 kilometer per hour has its component along this path as 2 cos 60. Why 60? Because this whole angle is of 150, out of which this is 90, so this will be equal to 60. So this as a projection on this will give you 2 into cos 60, which is equals to 1 kilometer per hour. So velocity along the width of the river is 1 kilometer per hour, width of the river is 1 kilometer. So the time taken to cross this will be equals to 1 hour. Coming to question number 34. N moles of a diatomic gas in a cylinder are at temperature T. Heat is supplied to the cylinder such that the temperature remains constant, but N moles of the diatomic gases get converted into monoatomic gases. What is the change in the total kinetic energy of the gas? See, when the diatomic gas is converted into monoatomic gas, the degree of freedom is changing, right? So degree of freedom may change from your 5 by 2 to 3 by 2, right? So let's see the solution. Yes, the energy potential energy U is given as F by 2 into N into RT, where N is the number of mole, F is the degree of freedom, right? So for a diatomic gas, it becomes U is equals to 5 by 2 nRT, and at the same time for monoatomic gas, it becomes 3 by 2 nRT. Now when the diatomic gas is converting into, when suppose n moles of diatomic gas is converting into monoatomic, then the number of moles will automatically become double, so it becomes 2n. So U will be equals to 5 by 2 n minus n. Why n minus n? Because small n number of moles is converted into monoatomic gas, and diatomic is left of capital N minus n into RT plus 3 by 2 into 2n. This is the number of moles of gas converted into, means a number of mole of particles present after the conversion of diatomic gas into monoatomic gas, right? So from here, this is the final internal energy of the system, and this is the initial internal energy of the system. Difference of this will give us the total energy of the system, and calculating it we get nRT by 2. So the correct answer for question number 34 is nRT by 2, which is the option 4, right? So question number 34 has its correct answer as option 4. Coming to question number 35, the magnetic field due to a current carrying circular loop of radius 3 centimeter at a point on its axis at a distance of 4 centimeter from the center is 54 millitesla. What is the value of the center of the loop? Okay, so the magnetic field along the axis of the coil is given by mu naught upon 4 mu naught into I r square upon 2 r square plus x square raised to the power of 3 by 2, and that at the center it is given as b dash is equals to mu naught I upon 2r, right? Finding this ratio and then putting the values, we get that b at the center is equals to 250 millitesla. So if we remember the formula, simply we have to put the values in it and we'll get calculated, and we get the answer as question number 35 as your answer as 250 millitesla, right? So at the axis, the formula uses b is equals to mu naught I into r square upon 2 r square plus x square whole raised to the power of 3 by 2, and at the center it becomes mu naught I upon 2r, right? Putting these values, we get the answer as 250 millitesla. Coming to question number 36. A spherical liquid drop of radius 7 cm is divided into 27 equal droplets. If the surface tension is 2 into 10 to the power of minus 3 Newton per meter, then the work done in the process is. So, radius of the drop is 7 cm. Volume of the larger drop will be equals to 4 by 3 pi capital R cube, and volume of the smaller drop will be equals to 4 by 3 pi into small r cube. Now 27 drops of volume V will be equals to V naught. This is the volume of a single drop, right? So 27 into 4 by 3 into pi small r cube is equals to 4 by 3 pi capital R cube. From here we get the relation that capital R is equals to 3 times of R. That is the radius of the larger drop. Single drop is equals to 3 times the radius of the smaller drop, right? So the surface tension initially it is SI is equals to 4 by 3 pi R square into S naught. That is the surface tension. And finally it becomes S2 is equals to 27 into 4 pi R square into S naught, right? So work done will be the difference between the two surface tensions. So subtracting the two surface tensions, we get it as 2.5 10 to the power of minus 4 joule. 2.5 10 to the power of minus 4 joule, which is option 4, right? Now coming to question number 37. The physical quantity energy density has the same dimensional formula as pressure, stress, Young's modulus of elasticity, all of these. See, here itself we see that this pressure, stress and Young's modulus, all three have the same dimensional formula. Pressure is force upon area, stress is also force upon area, and Young's modulus is force upon area upon delta L upon L. Delta L upon L do not have any dimension or they do not have any unit. So all the three, option 1, 2 and 3 are having F by A, F by A and F by A. So obviously the correct answer will be option 4, that is all of these, right? And that is the energy density also have the same dimension. So question number 37 has its correct answer as option 4. Coming to question number 38, when two particles having charge Q1 and Q2 are kept at a certain distance, they exert a force of F on each other. Now, if distance between the two particles is reduced to half and the charge on each particle is doubled, then the force between them would. So see, F is proportional to Q1 Q2 upon R square. So distance is halved. So it becomes R by 2 square. So we'll multiply with 4 in the numerator. And the charges are doubled. So 2 into 2. So this becomes 16 times, right? So the initial force, if the initial force is F, so the final force will be equals to 16 F. So the correct answer for question number 38 is option 4, that is 16 F. Coming to question number 39, it says the current through the 25 ohm resistor as shown in the figure. So this is a Wheatstone bridge and it is balanced because this and this has a ratio of 1:2. This and this also have a ratio of 1:2. So P by Q is equals to R by S. So the Wheatstone is balanced. So there will be no current in this resistor. So the correct answer is option 4, which is 0. Assertion and reason. A body can have acceleration even if the velocity is 0 at a given instant of time. A body is momentarily at rest when it reverses its direction of motion. Yes. Simplest example, if you are throwing a ball vertically upward, it reaches to the maximum height. At this height, we know that the velocity is equals to 0 and again then starts falling down. In this whole journey of going up and coming down, it is experiencing an acceleration which is known as acceleration due to gravity. It is always present there, right? So this object thrown vertically upward is always having acceleration even at the instant of reaching the maximum height where its velocity is 0, that is it is at rest for a moment. So at that moment, although its velocity is 0, it is experiencing an acceleration which is nothing but the acceleration due to gravity. So the assertion and reason both are correct. So according to this, the correct answer will be option 1, that both assertion and reason are correct and reason is the correct explanation for the assertion. Coming to question number 41. 41 says that a particle is projected with a speed of u at an angle of theta with a horizontal. If its parabolic path at a point the particle is moving at a right angle to the initial direction of projection. So its velocity at that point is, so see, initial velocity we take it as u is equals to u cos theta into I cap plus u sin theta into j cap. This will be our initial velocity. Final velocity we take it as u cos theta into I cap because x component does not changes and y component would decrease by gt, that is because the acceleration due to gravity is in the opposite direction. So it will be equals to, using v is equals to u plus at, we get final velocity in y-axis as u sin theta minus gt into j cap, right? So this is the initial velocity and this is the final velocity. For the final, yes, for the final velocity to be perpendicular to the initial velocity, their cross product should, sorry, their dot product should be equals to 0. So if we find that dot product, it comes as u square cos square theta plus u sin theta into sin theta minus gt, and solving this we get our as u square ug sin theta equals to 0, we get t is equals to u upon g sin theta. Now putting this value of t in the expression of final velocity, we get our final velocity as u cot theta, right? U cot theta. So the correct answer for question 41 is option 2, that is u cot theta. Now coming to question 42, the two insulated charge conductor spheres of radius 20 centimeter and 15 centimeter respectively and having equal charge 10 microcoulomb are connected with a copper wire and then they are separated. Sorry. Then the surface charge density on the two spheres will be equal. Surface charge density on the 15 centimeter sphere will be greater than that on the 20 centimeter sphere, and surface charge density on the 20 centimeter sphere will be greater than that on the 15 centimeter sphere, or both sphere will have the same charge. See, when the spheres are connected with each other, the charge will flow till the potential of each sphere becomes same. So potential is given by V is equals to 1 by 4 pi epsilon naught Q upon R. So if both are having the same charge, so their potential V1 will be equals to Q upon R1 and V2 will be equals to Q upon R2, right? And when they are connected, this Q upon, now when they are connected, the charges will flow from one body to another. So it will become Q1 upon R1 is equals to Q2 upon R2, right? So from here we can say that, let me see here, it will be Q1 upon Q2 is equals to R1 upon R2, rearranging it. Now surface charge density is equals to Q upon 4 pi R square. So surface charge density sigma 1 will be equals to Q1 upon, Q1 upon 4 pi R square, right? And sigma 2 will be equals to Q2 upon 4 pi R2 square. So from here we can say that sigma 1 upon sigma 2 is equals to Q1 upon Q2 into R2 square upon R1 square, right? And from here we have seen that Q1 upon Q2 is equals to R1 upon R2, right? So Q1 upon Q2 can be written as R1 upon R2 into R2 square upon R1 square. So this will finally give us R2 upon R1, right? So finally we get what we get, where to write? We get we get so finally we will get sigma 1 upon sigma 2 is equals to R2 upon R1, right? So surface charge density is inversely proportional to radius. It means surface charge density will be uh, greater for 15 centimeters. So surface charge density on 15 centimeter sphere will be greater than that on the 20 centimeters. So the correct answer for 42 will be option 2, right? Coming to question number 43. A uniform cube of side A and mass M rests on a rough horizontal table, and horizontal force F is applied normally to one of the face at a point that is directly above the center of the face at a height of 3a by 4 above the base. The minimum value of F for which the cube begins to topple about its edge. Okay, so for this question, see the yeah, when the block will be toppling, it will lose contact with the surface. So there will be no normal reaction force acting here. All normal reaction force will be acting at this point. And this is the point of turning. So about this point, this force is acting like this, right? So this will cause a turning effect in this direction. Whereas we have the weight of the body which will cause a turning effect in counterclockwise direction about this point, right? So the minimum force required can be obtained by equating the two torques, right? So equating the two torques means we'll have to multiply F with the distance is 3 by 4a, 3 by 4a, and this torque, this is clockwise torque, should be equal to the anti-clockwise torque, which is equals to your mg into distance is a by 2, a by 2. So we need to calculate the value of f. So this a and a cancels out. 2 ones are 2 twos are. So we get f is equals to 2 by 3 mg. F is equals to 2 by 3 mg. So the correct answer for question number 43 is option 2, that is 2 by 3 mg. Question number 44. If a small sphere of mass m and charge q is hung from a silk thread at an angle of theta with the surface of the vertical charge conducting plates, then the equilibrium of the sphere, for the equilibrium of the sphere, the surface charge density of the plate is. See the diagram, we can see it from here itself, not that clear. See, if this is the plate and this is the thread and this is the bob, so there will be a tension T. Here it is experiencing a force which is an electrostatic force, and in this direction it is experiencing a force which is its weight. Now if we resolve this is making an angle theta. If this is theta, then this angle will also be theta. So this side tension can be resolved as T cos theta, and here it will be equals to T sin theta. Now T cos theta is equals to mg and T sin theta is equals to QE. And electric field intensity, because of our infinite sheet of charge is sigma upon epsilon naught, right? So this can be written as Q into sigma upon epsilon naught, right? Now for equilibrium, this is the equation. Now dividing these two equations, we get tan theta. We get tan theta is equals to QE upon mg. Now putting E as sigma upon E, we get tan theta is equals to Q upon mg into sigma upon epsilon naught, right? So therefore your sigma will be equals to mg upon Q into epsilon naught tan theta. So that is your option 1. Option 1. So again, if you understand, this is QE, this is mg, this is T, this is P cos theta, because if this is theta, this will also be equals to theta, and this is T sin theta. Now this is no more, it is in equilibrium, so P cos theta will be equals to mg and T sin theta will be equals to Q into E, and E is sigma upon epsilon naught, right? So putting these values and solving, we'll get the value of sigma. Coming to question number 45, it says a rectangular loop of slides or rectangular loop with a sliding connector P2 of length L is equals to 1 meter is situated in a uniform magnetic field B is equals to 2 Tesla perpendicular to the plane of loop. Resistance of the connector is R is equals to 2 ohm. Two resistances of 6 ohm and 3 ohm are connected as shown in the figure. The external force required to keep the connector moving with a constant velocity V is equals to 2 meter per second is. See, this is the setup which they have shown or told in the exam, in the question. So the force is given by B is equals to IBL. F is equals to IBL. I is induced EMF upon resistance. Induced EMF is the motional EMF over here, and that motional EMF can be given by the formula BLV. So the formula for the force become B square into L square into V upon R. Putting the value of R as 4 ohm, because this is 6 and 3 in parallel, this would result in 2 as equivalent, and this 2 and this 2 are becomes in series, so become total resistance as 4. So putting R as 4, B is being given to us as 2, and value of V. Finally, putting the value, we get F is equals to 2 Newton, right? So the correct answer for question number 45 is option 3, that is 2 Newton, right? So F is equals to IBL, I is E upon R. What is E? E is the induced EMF over here, which is also the motional EMF. Motional EMF is given as E is equals to BLV. Putting the value as BLV, we get the formula for force in terms of B, L, V and R. And all the three B, L, V and R values are given in the question. Putting those values in the equation, we get the value of force as 2 Newton. Coming to question number 46. Question number 46. Two condensers, one of capacity C and another of capacity C by 2 are connected in to a battery V of voltage V to a V volt battery as shown in the figure. The work done in charging fully with the both condenser is. So first calculate the equivalent conductance. So equivalent capacitance will be equals to 3 by 2 C. So energy will be equals to half CV square. So half into C is 3 by 2 into C into V square. So it will be equals to 3 by 4 CV square. 3 by 4 CV square is option 4. Next, Coming to question number 47, it gives that the acceleration versus time graph of a particle moving along a straight line is shown in the figure. The respective velocity time graph. So from the acceleration time graph, we need to calculate velocity time graph. So acceleration time graph, acceleration is constant for first 2 seconds, then 0 for next 2 seconds. Means here the velocity is increasing, here the velocity is constant. So if we look into the graph, velocity is increasing, velocity is constant. Velocity is increasing, velocity has become 0. So this is not the correct graph. Velocity is increasing, velocity is constant. Okay, and no, velocity is increasing, velocity is constant, but it abruptly changing its value, which is again not correct. So option 3 is also not correct. Coming to option 4, that is yes, no. So velocity is also not increasing here initially. So finally we have our option 1 as the correct answer. Option 1 as the correct answer. So correct answer for question number 47 is option 1. Coming to question number 48. Where 48 says a surface area or area vector 2i cap plus 3j cap meter square. Find the flux of an electric field through it if the field is given as 4i cap. See, flux phi is equals to E dot A, both in the vector form. So E and A are given in the vector form. If we find the dot product, it will be 8, because 4i into 2i will give me 8, and for j it's 0, so it becomes 8. So the correct answer for question 48 is option 1, that is 8 volt meter, right? Next, coming to question number 49. 49 says that a bullet of mass 0.01 kg traveling at a speed of 500 meter per second strikes a block of mass 2 kg which is suspended to a string of length 5 meter. The center of gravity of the block is found to rise vertical distance of 0.2 meter. What is the speed of the bullet after emerging from the block? So here we will have to use two concepts. One is the law of conservation of linear momentum, and another is law of conservation of energy. So according to law of conservation of linear momentum, because no external force has been applied, the momentum of the system initially should be equal to momentum is from finally. So initially the block is not in motion, but the bullet is moving with a velocity of 500 meter per second. So P initial will be equals to 0.01 into 500 plus 2 into 0. 2 is 2 kg for the block, right? So P initial comes out to be 5. P final will be equals to 0.01 into V1, that is the velocity of the bullet after passing through the block, and 2 into V2, that is the velocity of the block. So we get 0.01 V1 plus 2 times of V2 is equals to 5, right? Yes. Now by law of conservation of law of conservation of energy, for the block its kinetic energy, that is half into mass of the block into its velocity. Velocity of the block is finally V2. So V2 square is converted into its potential energy, which takes it to a height of 0.2 meter. So it will be equals to m into g into h is 0.2. So from here we get this 2 and 2 cancels out. We get V2 square is equals to 4. So we'll get V2 is equals to 4. Now putting this value of V2 here, it becomes 0.01 V1 is equals to 8 is equals to 5. Right? Why it is coming negative? 4, 4, 4, 4 into 8. So here is the mistake. It's not 4 because it had become root. So it will be equals to 2. Putting 2 here, this will be equals to plus 4. So this 4 goes that side. So we get 0. We get 0.01 V1 is equals to 1. So we get V1 is equals to 100. So the correct answer for question number 49 is option 1, that is 100 meter per second. Right? Coming to the last question, that is 50th question, that the when current supplied by a cell to a circuit is 0.3 ampere, its terminal potential difference is 0.9 volt. When the current supplied becomes 0.25 amperes, its terminal potential difference becomes 1 volt. The internal resistance of the cell is. So, see, we have the formula E is equals to V plus I into R. So, E is going to be same, but what is happening is, let me write it as E1 is equals to V1 is 0.9, it is 0.9 terminal voltage, plus at that time the current is 3 amperes, sorry, 0.3 amperes. So it is 0.3 amperes into R, and E2 will be equals to 1 volt. E2 is equals to 1 volt, sorry, E2 not, terminal voltage is equals to 1 volt plus 2.5 into R, right? So the EMF is same. EMF is same. So using this and solving, we get 0.9 plus 0.3 R is equals to 1 plus 2.5 R. Now solving this equation for R, we will get R is equals to 2 ohm, right? So the correct answer for this question number 50 is 2 ohms, that is option 2 is the correct answer, right? So that is all. So I hope you understood the solution for each question. If you have any problem in any of the question, if you do not understand it, please mention it in the comment box, right? And that is all from my side for your BPT 18. Thank you.